In this video, we will explore the dodSON.Core.Networking namespace. We will start by creating a console application and making a reference to the dodSON.Core assembly. Adding a using directive to the dodSON.Core.Cryptography namespace provides access to some extensions. First, we will create a pair of file-based logs, one for the server and another one for the clients. See the Programming with the dodSON.Core.Logging namespace video for more information. Next, we will create the server. The server requires a channel address, a server configuration, a transport controller, and a log source ID. A channel address consists of an IP address, the port, and the name of the connection. For all intents and purposes, it is an abstraction of a URI. The server configuration contains the server's unique ID. The transport controller is used to control the transportation layer. It requires a transport configuration and a registration controller. All messages are transmitted by converting them to byte arrays, compressing and encrypting them, and breaking them down into smaller chunks called envelopes. It is important to note that the server only deals with envelopes. The transport configuration enables the encryption, compression, and the splitting and combining of messages into envelopes. The envelope cache time limit is used to control the amount of time envelopes for an incomplete message will be held before the message is abandoned. And the seen message cache time limit controls message flow in networks with interconnected topologies. The registration controller defines properties and methods used to control registering and unregistering clients and challenging those clients for access to the communication system. The challenge controller will verify that the user has the proper evidence before allowing access to the communication system. Hooking into the server's activity log event will allow us to write any logs that are generated by the server to the server's log. Next, we will create a client. The client requires a channel address, a client configuration, and a registration controller. We will use the same channel address that we created for the server because we want to connect to the server's communication channel. The client configuration contains the unique ID for the client and whether or not it should receive its own messages. The registration controller contains a challenge controller. We will use the same challenge controller that we used for the server because we want to connect to the server's communication challenge, and we must have the same challenge controller and evidence. Hooking into the client's message bus will allow us to write the received message to the client log and the console. We will also include the client ID of the client who sent the message and the client ID for whom the message was sent to. We will then wait 1 second and send a message directly to the client that sent the message. This will set up a message oscillation. Client 1 will receive a message from Client 2 and then send a message back to Client 2. Client 2 will then receive a message from Client 1 and send a message back to Client 1, and so on and so forth. Next, we will create Client 2. Client 2 is virtually the same as Client 1. Finally, we will send an initial seed message. By setting the target ID to blank, we are telling the communication system to send this message to all clients. Client 1 will not receive the seed message because it has been configured not to receive its own messages. Then we will simply wait until the user presses any key. When the user presses any key, we will close Client 1, close Client 2, and then close the server. Finally, we will close both logs and again wait for the user to press any key, allowing the user to see the results before the console application terminates. Compiling and running the application shows the logs, the server, and the clients being created, and then finally the seed message is sent. After that, we can see messages being bounced between client 1 and client 2. When any key is pressed, the clients, the server, and the logs are closed, and the application waits for any key to be pressed. When we open the server log, we can see that a named pipe server was created along with its URI. We can see that a client was registered. This is the server's internal client. Next, we see client 1 and client 2 being registered. By not declaring any receivable and transmittable message types, the client will receive all message types. After 21 seconds, we see that client 1 and client 2 are unregistered with the server, and that the server itself is shut down, displaying some basic statistics. Remember, the server only deals with envelopes. Opening the client log, we can see that client 2 received the initial seed message. Client 1 did not receive the seed message because it sent the message and has been configured not to receive its own messages. The rest of the log shows messages being bounced between client 1 and client 2. By simply changing the server and clients from named pipes to TCP and leaving everything else the same, we can change the underlying communication transport mode from named pipes to TCP. Running the application shows that it operates just like before. Opening the server log shows a similar log, except that the server and clients are now TCP instead of named pipes. The client log is also the same. Similarly, we can also change our transport mode to HTTP by changing the server and client types. Once started, we can bring up Progress Telerik Fiddler and see the HTTP traffic. Selecting one at random shows an envelope. An envelope is made up of a header and a payload, both of which are compressed and encrypted. Again, we can see that the server and client logs contain the proper log entries. This video demonstrates some of the basic functionality of the dodSON.Core.Networking namespace. The dodSON.Core.Networking namespace provides a feature-rich communication system that is easy to use. It encompasses all three major transport modes, restricts access by challenging clients, provides security with configurable compression and encryption formats, automatically splits messages into envelopes to support virtually unlimited message sizes on network transports with restricted size limits, for example, named pipes, allows direct messaging by sending messages directly to specific clients by client ID, thereby reducing network traffic, and supports any network topology from line and star to fully connected. See the dodSON software library help file for more information.